All right, so somebody help me out. Just start off with just the basic absolute value of x. Can you take a moment and graph kind of a nice graph of that? So meaning, don't just go, no, give yourself some scale, give me some outputs, make us kind of a nice graph.
Is this chapter 4?
No, we still have to finish 3. So this is 3.6. Yeah, we stopped at 3.5 for the test. Yeah. So don't get too excited. 3.6, 3.7, I didn't throw them out. They're just going to be on the next test. Yeah. So make a nice little graph. 1, 2, 3, 1, 2, 3, 1, 2, 3. Sure, we'll put some negatives, but we know they're not going to be used. Poor little dudes, right? So I use what I call my anchor points. So my anchor points for absolute value are 0, 0. What's another point? 1, 1. And what's another point back this way? Negative 1, 1. So those are my anchor points. This is the base look of an absolute value. Now, some of you guys might know where I'm headed. Let's make this really nice. 1, 2, 3, 1, 2, 3, blah, blah, blah. Okay. What would this do?
Shift to the left. Right.
To the right. That's right. To the right now. Sorry. So I got to go shift right 1. So that would take this picture. Colors don't show up on this stupid projector. Let's see if they do. And I would shift every point. All I have to do, so I identify that it's right 1. And so I take every point and I just move it over 1, over 1, over 1, and then I just graph the shape again. That's all that's involved with that kind of thing. That was, I forget which number it was on the test. 2D. All right, so then what would... Come here. Oh, there's orange. Freaky. What would this do? Yeah, what does that do?
It's a reflection.
Reflection. It's not inside with the x, so it's not this, it's not left and right, it's up and down, correct? Remember, inside the x, left, right. Outside, up, down. So that's going to reflect around the x-axis. So I can just kind of do that. This would go here, this would go here. Now I'm not done yet. That's sort of like an intermediate step, because then what do I have to do with each of those points? Go up 2. So this goes up 2. This goes up 2, this goes up 2, and now I got this thing going on. Yeehaw! All right, the colors show up, sort of, for the most part, especially the orange. So you don't have to do this, and if I were a student in here, I probably wouldn't do this either, but the people that use little color pencils for these, they kick so much ass. Just throw that out there. You don't have to. But you do have to show me the base function, and then show me the new function. How would I check what I just did? The orange. What point, what's this point right there? 1, 1. So if I plug a 1 in, I'm supposed to get a 1 out, and sure enough, what's the absolute value? 1? Holy shit. And what's negative 1 plus 2? 1. So yes, I plugged a 1 in, I got a 1 out. I can check my work when I do these transformations. Does that make sense? It's always good to know how to check your work. Now, of course, the ultimate way to check your work is just to throw this damn thing into your calculator and just look what it does, but you know you're not always going to be able to use those, so. Okay. All right, not too bad, right? So this is marrying the idea of transformations with another function. So every function we learn this semester, we're going to have to learn how to move it around, which is not going to be brand new. If it's in with the x, left to right. If it's outside, up, down. Always the same. You guys semi with me? Anybody totally with me? Okay. Yes?
What would you do if you had h of x equals 4 and absolute
Let's make it m of x
Like when I
equals.
searched it up, it says that.
Wait, what's it? What is it again? Sorry.
So it's 4, and it's absolute value of x minus 2, and then like plus 5.
Okay. So what are the transformations? What's this one?
It's going to the right.
Which transformation do I do last?
The last one or the first?
Plus 5. Order operations. What does it do? It saves your ass. So I would do the plus 5 last. So what's this do?
Changes the slope.
Okay, changes the slope, multiplies all the outputs by 4, vertically stretches it. I'll accept a bunch of different shit there, right? So the most obvious, the best way is multiply outputs by 4, or you can say vertical stretch, or there's a few things you could say there, right? And then, of course, the last thing I do is up 5. Not in with the x, up and down, that's up 5. Cool, so then my base graph would look like this. 0, 0, 1, 1, negative 1, negative 1. I would dot it. That's my base graph. It's not the answer, so I'm not going to make it a solid line. Yes?
Why does it matter that you're going by order when you're just graphing?
Oh shit, I forgot I got to multiply by 4. Shit. I need a better scale. Go ahead.
Why does it matter, like the order of operation if you're just graphing? Like, can't you just go up 5 first and then?
No. If you go, now listen. Okay, I love this question. All right, so real quick, I got to regraph this anyway. Does everybody understand? It's perfectly fine because you're going to be working in pencil, so you'll be able to erase your shit. Do you notice what I realized after I did this?
That you have to multiply by 4.
It'll still work. That's right, because the lowest output I have is 1. So I'll be able to do it here. Okay, but real quick, I want this to make sense, obviously, always. If I move everything up 5 first, and then, so move 1, 2, 3, 4, 5, and then multiply all my outputs by 4, isn't that going to go to 20? That's not where it's supposed to be. Do you guys understand? So this says, take the graph of this, so you got to figure out what that is first, and then add 5 to all the outputs. So I can't add 5 first because I got to know what those are before I can add 5. Does that make sense? And of course, it's not just I'm making you do it because I'm making you do it because otherwise it comes out wrong. Okay. So let's see. I think I can salvage this. So if I multiply, it's got to go up 5 also. Damn you. All right. Let me see. So part of any problem is making a mistake first. Okay. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
So do you just multiply each like input by 4?
Each output by 4. Because that's outside. It's going to affect the up and down. So I would take my
And if
base.
it was
Go ahead.
on the inside, then it would affect the input.
That's right.
Okay.
So I would take right 2. Every point goes right 2. So I'm going to do this in stages. So this point goes right 2. This point goes right 2. And this point goes right 2. So I'm right there right now. That's the first step. Then I want to multiply all my outputs by 4. So 4 times 0 is 0. 4 times 1 is 4. 4 times 1 is 4. So now it looks like that. And whoever said increase the slope, you can see how that totally makes sense. And then, I got one more color. I want to take all my points now and add 5. Do you see how I'm just doing it progressively? Wherever the points end up, the next thing I do to those new points. It's kind of nice. It's not hard. It's just you're not used to it. So now every point goes up 5. Did I give myself enough room? Yes. Up 5 goes to 9. Up 5 goes to 9. Up 5 goes to 5. And now there's my final answer. So this point right there is the point 1, 9, correct? Let's see if that works. If I plug a 1 in, do I get a 9 out? What's 1 minus 2? Negative 1. Absolute value negative 1? 1 times 4. 4 plus 5. 9. Okay, sweet. Do you guys understand what I just did? My final graph went through a point. Any point it goes through, I could pick it and make sure it actually works in the equation. That tells me that it looks like I'm good. Let me stop for a moment. So this semester we're going to talk about several functions you've seen. We're going to talk about some functions some of you guys have never seen. Is there anybody who's never seen the graph of tangent x? Anybody ever heard of tangent x?
Isn't that the one that's like the...
True. Anybody never heard of tangent x? So you guys obviously don't know what it looks like, correct? But if I gave you tangent x and you knew the shape of it, and I said, now do tangent x plus 1, you would just take it, right? I don't give a shit what the function is. How does it move around? They all move around the same way. That's kind of beautiful. So once you understand the minus 2 inside means right 2. If it was outside, it would be down 2, and blah, blah, blah. If you understand that, I don't care what the function is. They all work the same. That kind of kicks a lot of ass. Thank the gods, right? You just have to understand one thing and apply it to multiple things. Kick ass. Okay. Now, so that is all I'm going to say about that, because we've talked about absolute value before, we've talked about transformations before, so that section is kind of nice. Nothing really new in it. So here's some new stuff. What would you say the inverse, if f of x is 2x, how do I want to say this? Yeah. If f of x is 2x, what would you say the inverse function is? So what does this function do to something? Doubles it. So what would the inverse function look like? What would it do? Yeah, so the inverse function, so it'd be x over 2. Is that okay by itself, that idea? Inverse means it undoes whatever the original function did. So if the original function takes 4 and makes it 8, the inverse function takes 8 and divides by 2 makes it 4 again. It just takes it back to where it was. Is that cool? Now, why wouldn't I want to call this new function, just call it g of x? Because isn't it related to f? Isn't that how it was created? I had to be given an f and then I created this. So somehow it should reference f. It's not its own function. It's the opposite of the function I was given. So shouldn't there be a symbol that says, oh yeah, this shit's related to the f thing? Does that make sense?
Negative the f of x or something?
Oh, yeah, we're getting there. So instead of that, we're going to use the symbol, which is really unfortunate. It's a really unfortunate choice.
Just negative.
No, because that means change the sign. Does anyone see why that's a really unfortunate choice?
Because it looks like exponents.
True, it looks like exponents. Can somebody tell me what would this be? What is f of x?
2x.
2x. Good. What's this mean? What's this mean?
1/2.
Flip it, right? Okay. Is that what this is?
No.
Nope. So, unfortunate decision that was made in the past by a lot of old white dudes. We weren't around to go, excuse me, that's not a good idea. So too bad for us, we just have to live with it. So we have to understand, if I see an f with a -1 on it, it's not a power, it means the inverse function. Doesn't mean 1 over, it means the opposite. And those are not the same thing. You guys with me? Okay, I like it. I like it a lot. Now, is this a relatively easy function? How much time do I have? Okay. I would say that's a freaking easy, you're like, give me that function, Jeff, right? So what if I said this? What if I said, okay, do everything we just did for this instead. Find the inverse of this. You ready? I want to know the inverse of this function. 4 cube root of 1 minus 5x plus 7. Can you do the same thing we did up here? What did we do here? We just said, okay, the opposite of doubling is cutting in half. Yay. Okay. What the shit? Is there a little more going on now? You agree with me? Now let me ask you this though. Let me ask you this. What does our current function do? Give me one thing it does. And I'll start us off. It adds 7. You guys agree with me? So shouldn't our inverse function subtract 7 somewhere?
Yes.
What else does our function do? Give me one thing.
It's the square root.
Multiplies by what? 4. So shouldn't our inverse function somewhere divide by 4? What else does it do?
It's a square
Cube
root.
roots, right?
Yeah.
So what should our inverse function do? What's the opposite of cube root? Cube. So our inverse function should have a cube in it, should have a -7, it should have a divided by 4. Doesn't it also multiply by -5 inside? Do you guys see what I'm saying? So, okay.
Okay.
My God, what order do we do all that shit in though?
Well, you have to do it in the same order as.
No, you do it in the opposite order. So we need a process that if I follow it, everything just falls into place. Does that sound good? I agree. So here's the idea. What did this take the place of? Didn't it take the place of y? So this doesn't seem like a big step, but it sort of is. So I really didn't do much, did I? Good job, Jeff. Let me see if you guys are cool with this. What does an inverse function do? Come back up here real quick. You don't have to write this, but just answer me this. What's f of 3? 6. And this is x and this is y, correct? What is f inverse of 6? You can do it, right? 6 divided by 2, but also, doesn't it just make sense? Shouldn't the inverse function take the output and bring it back to where it was? That's what its job is. The inverse function is supposed to undo whatever the original function did. Does that make sense? That's why you guys knew the inverse was divided by, because it undoes multiplication, right? Maybe. So what the shit are you talking about, Jeff? I don't know. Hold on. Yeah?
So if f of x equals 2x, why isn't the inverse function 2 over x?
Because, all right, give me a number. Everybody all right? Okay, dear God. That was freaky. It sounded like a whole body fell over.
It did.
Okay, sorry, where were we?
So if f of x is equals
I need a drink
2x,
to calm my nerves.
why is the inverse function x over 2 instead of 2 over x?
So double, give me a number. Give me a number.
6,
Double it.
12,
What do you do to get it back to 6?
divide
By 2.
12. Oh,
Right? So the whole idea of inverse is if some function comes along and does something, so that's my 6, and this function came along and doubled, I'm like, you! And then it cut it in half, so then it's back to what I wanted. Does that make sense?
so
The inverse function's job is to undo what the original function did.
okay. Oh, because it's multiplying by 2, you then have to divide.
5 by 2,
Okay.
exactly.
Okay, that makes sense.
Now, we will come back to the 2 over x thing.
Okay.
Something related to it, yeah. All right. So here's the whole idea. Do you see how inverse functions switch the x and y? Isn't the y sort of the input now? Do you guys agree? Do you see how that happens? There wasn't 6 the output?
Yeah.
So if I put an output into the inverse, the original input comes back out. You with me? Now watch this. So this is so cool. This is so cool. I draw a little dotted line because we're going to do something weird. This is nothing algebraic. This is the idea. So I'm going to switch the x and y. Because that's what the inverse function does. Now, I'm going to solve for y. So this is going to make sense in a whole other way. If I want to solve this equation for y, and I agree, it is gross, but who gives a shit? Which term is my x in? This term here, I'm sorry, my y is in this term, correct?
Uh-huh.
So I want to get that term by itself. So I want to get rid of him. What do I do?
Subtract.
Aren't we doing the so as I solve for y, am I not going to start doing all the opposite operations in the opposite order? You can see, isn't that what inverse is supposed to do? So -7, x minus 7 equals all this shit. What do I do next? Divide by 4. I love it. Divide by 4. Divide by 4. Let me take it over here. X minus 7 over 4 equals cube root of 1 minus 5y. Now, there's a definite thing you have to do next. Let me stop right now. Is everybody with me? The weird part about this is switching the x and the y, which is why I personally just always put a dotted line to remind myself, future me, what the hell happened, weird shit happened. I applied the idea of inverse. That's the only way you could do this. It's not something that's allowed in algebra. We're just applying an idea. What's the next thing I need to do here? Good. I'm trying to get my y by itself. It's stuck in a cube root. I'm going to cube both sides. Huge thing right now. Do not cube x minus 7. But you can cube 4. Does anybody know what 4 cubed is? 64. There is no reason to multiply that out. You guys understand what I'm saying? Because you're going to get some fifth roots and you got a fifth power. My God, do not. I always get people that multiply that out. Like, no reason to do that. Right? Okay. And what's left on the other side? Well, still the... You guys all with me? Here's something I'm going to just say directly, which I don't think anybody's ever said to you directly. Whenever you have your variable is minusing on one side, I really want this to make sense. I could just switch these. Watch this. What's 10 minus 2?
8.
Holy shit. What's 10 minus 8? Do you see how those are switched? A whole thing minus a part is the other part. Now, couldn't I add 5y to this side? Yes. Couldn't I then subtract this to this side? Wouldn't that do what I just said? You're in 176. We're going to have some big-ass freaking equations. You got to start learning some shortcuts if you haven't done so yet. You got to start making your own shortcuts too. Maybe check them with me, but start making math your own thing. That's one huge thing with pre-calculus. You got to make it your own thing. So all I have to do now is switch these two around. And what's my last thing I have to do? Last thing.
Divide everything by 5.
Divide by 5. And this is my inverse function. So I would call it g inverse of x. Is that cool?
Mm-hmm.
Because the original function was g. So to identify that this guy is related to him, I use g, but I put a -1 to say inverse. Did it do everything? Okay, subtract 7. It's a little bit hidden because we made it 64, but doesn't it divide by 4? And it multiply by 4? It's 64 because we cubed the poor little dude. It cube rooted and we cubed. It multiplied by 5, we divided by 5, blah, blah, blah. Is that, you guys kind of with me? Okay. So there's a beautiful process to follow that if you just do it, everything falls into place. Maybe? Yes?
Okay, so why do we need an inverse function?
So let's say I'm given this function, right? And somebody says, can you fill in, and again, I know the next question is going to be, but let me let you ask that. And if somebody says, fill in this table. That's easy. How would I fill that in? I would just plug a 1 in, right? What would I have to do for each of these? Where would the 2 go? Is 2 what x is? 2 would have to go here, right? And then I have to solve for x. You with me? What do I have to do for 8? I plug in 8. Solve for x. I'll solve for x. Holy shit! Can't I just solve for x once and then answer all these damn questions? Right there, it is. Now I can just plug a 2 in here, an 8 in there, -11 there. It'll tell me the answer. So we want inverse functions because very often I need to know how to go both ways. That's one big thing with mathematics. You guys can all be jealous of math. It goes both ways. And this is a beautiful, perfect, in-your-face example of that. If I have a function, there must be, well, we'll get to that. There could be an inverse function. Oh, good. All right. Going off of what I just said. More paper. What are you? Good. Everybody with me so far? So this is the process for finding an inverse algebraically. When does an inverse exist? All right, to answer this, I want to look at this graphically. Graphically finding an inverse. And actually, I can kind of answer it in a different way too. If I tell you that I added 2 to a number and I got 5, can you tell me exactly what number I had? I added 2 to the number I got and I got 5. 3. Remarkable. We're all incredible detectives when it's a pretty simple function. If I said I squared a number and I got 9, can you tell me exactly what number I used?
3.
Nope.
81.
Nope.
No.
81 squared is not 9. Went the wrong way. I have a number, I squared it, and I got 9. I need to know exactly what number I used. Can you tell me exactly what number I used? Do you know for sure what number I used? Nope. You with me? So do you guys understand the difference between this? There are functions where the outputs lead right back to only one possible input. Does that make sense? If I tell you I added 2 to a number and I got 5, the only freaking possibility is 3. Yes? If I tell you I squared a number and got 9, is there only one thing it could be? If you had to put all your money on one bet, would you do it? Shit, no. That's 50-50. Are you kidding me? You guys kind of with me? A little bit? You might put $1 on something. Okay. Maybe? So, in order for an inverse to exist, what does it take to be a function? Every input can have only one output. That's to be a function. To also have an inverse, every output must come from only one input. Because what's the only way I can work backwards is if it could only come from one place. Why were you guys able to work backwards? And I said I added 2 and got 5, because it can only come from 3. Yes? If I said I squared something and got 9, you can't work directly backwards. It's 2 things it could be. So it's sort of like a detective thing, right? In the first case, it could only be Johnson. Put him in jail, right? Or give him a trial. Let me not preempt the whole judicial system. In the other case, it's like it could be Brad or it could be Chad. Shit. And now we got to figure out some more shit. So, all right. So I went that way. So in order for an inverse to exist, it's got to be what's called 1-to-1. And I love that name because not only does every input go to only one output, but every output must come from only one input, 1-to-1. One input to one output to one input, 1-to-1. That's a cool name. I like that. Yes, it's coming. I love it. So graphically finding an inverse. So I'm going to make a very funky looking function. Okay, here. Oh, I made this not very interesting. Too bad for you guys. Here, here. Okay. Can somebody remind me, what was the first step we did when I was trying to find an inverse algebraically? What was the first thing we did?
The subtracted 7.
No.
No. You switch to x.
Switch the x and y. So visually, what will I do? What point is this? Let's call this f of x. So what points does f of x go through?
0.
Can you just rotate?
Negative.
Sort of, but not really.
Negative 4 to 0.
Is that cool? Negative 4, 0. Give me another point, somebody else. 2, 1. Somebody else, another point. 4, 4. I like it. So my inverse function is going to do the exact same thing that algebraically we do. Switch the x and y, because that's the main idea of inverse functions. They take the output of one and it becomes the input of the other one and vice versa. So what points will the inverse function go through? 0, negative 4. 1, 2. 4, 4. And that makes kind of a cool visual. So now it's 0, negative 4. 1, 2, 4, 4. Where's the mirror? Where's the symmetry? Isn't it through there? The mirror is the y equals x line. And why does that make sense? We switch the y and the x so it flips over the y equals x line. Is the green thing I just drew, is that a function? Why? No. I love it. That would be if I'm asking if it has an inverse.
One output.
It passes the
It passes the
vertical line test.
horizontal.
No, I'm just asking, is it a function? It passes the vertical line test. Haven't discussed the Holtz yet. Now watch this. Without even doing this, if I were to give you g of x, and it looks like this. It looks really, really crappy because it had a rough night, all right? Give it a break, poor little thing. So what if it looked like this? That sounded different. So it looks like this. If I try to find the inverse, I'm going to do this a little bit quickly. It'll be 0, negative 4. That's negative 1, 4, correct? So it'll be 4, negative 1. That's 0, negative 1, correct? So it'll be negative 1, 0. And then this is 4, 1, so it'll be 1, 4. All right? So it's going to look like this. Is the green line I just drew, is it a function? Why not? Doesn't pass the vertical line test. Now, let's be smart about this. Let's not even draw the stupid green line, because that was weird. It took some work. Why don't, instead of flipping the function and then checking it with a vertical line, why don't we take the original function and check it with a frickin' horizontal line? Why don't we just flip the test? To be a function, you must pass the vertical line test. To be an invertible function, you also have to pass the horizontal line test. Why? Because if I flip it and do a vertical, let me just not flip it and do a horizontal. Let me just save some frickin' time. So vertical line test, answers, is it a function? On top of that, the horizontal line test will say, is that function invertible? So very quickly, is this function invertible? Well, is that a function? Sorry.
No.
Forgot what I was going to do. No, so that's a quick one. That's not a function, so I don't even talk about if it's invertible or not. What about this? Is this function invertible? That was a little bit hard. I'm sorry. I didn't mean to make it that hard. I meant this to be sloping. Yeah, so it passes the vertical line test, so it's a function, and it passes the horizontal line test, so it's invertible. Obviously, what about a parabola? Any parabola?
No.
No.
It's a function, but it's not invertible. Do you guys see that? It's that nice. It's that quick. And why does it make sense that we have a horizontal line test? Because instead of flipping the graph, I just flip the test. That's why the horizontal line test exists. If I did invert it, would it be a function? Well, don't flip it. Just do this. Hopefully that makes sense. Okay. Okay. What time is it? I'll let you guys out early. Why not? So we finished up chapter 3. The first part of chapter 4 should be very easy. It's just talking about lines and slopes and such. We've already talked about that. Part of chapter 4 is going to be some of your favorite stuff. Some of your favorite stuff ever. Some word problem stuff. Yeah. We're going to see those. Those are going to pop up every now and again throughout the whole semester. So, just so you know, you get plenty of that. Yes. Which one? Sorry. Oh wow, that can't be all the way. Is that all the way zoomed out? I'm with you. Give it a second.
Is it still recording?
Oh yeah, sorry.